we're going to do the pizza party after the break once everybody's back. Yeah, I didn't want Sam to miss it, and I don't want Ava to miss it. All right, here we go. We are continuing on from yesterday. Somebody remind me, what's a critical number?
It's a number when you take the derivative and then set it equal to 0.
Okay, where the derivative is 0 or undefined. Okay, that is an important thing to recognize. Now, if I give you a continuous function on some interval, it's guaranteed, as long as it's continuous, to have an absolute max and an absolute min. That's the extreme value theorem. There are extremes to the function. When you're finding the absolute mins and maxes, it's going to happen at one of two places. It'll either occur at a critical number or where? The endpoints. Those are the two possibilities. Now, these become pretty powerful problems, like as far as setting stuff up here. I'm going to give us let's do a couple application problems. I think it might just be one. I might give you guys a bunch of time to do homework today. We are just continuing a little bit. Probably. Okay, here we go. I did. Is it late? I'm just teasing. Yes, I'll grab yours, okay? All right. Here we go. All right, I'm sorry. We have to be wordy. I'm sorry. Example. Constructing a rain gutter. We are just continuing. Yep. All right. We're constructing a rain gutter is what we're doing here. Okay. So can I be less wordy? Do you want a paragraph? Okay, I'm going to let you elect whether you want to write it. I think I need to write it so that everybody can see it. Here we go. A rain gutter. A rain gutter is constructed using a piece of aluminum, which, yep, I spell it the British way because it looks stupid the other way to me. A piece of aluminum, 12 inches wide.
That makes sense. Wait, they spell it different too?
This is British.
How do they spell it in American? I like aluminium.
Aluminium.
Sounds like a metal.
We pronounce it aluminum, so why would we
Aluminum
say
sounds like a light. It's like numerous.
Anyway, this is how the British spell it, and it makes more sense to me. I don't know. Here we go.
Even though I don't know.
Okay. Here we go. After marking a length of 4 inches, after marking a length of 4 inches, the piece is folded at theta, or at an angle of theta. The pieces are folded up at angle theta. Okay. The area what's up? Okay. This guy. The area, capital A, of a cross section of the opening is, and here we go, A of theta is equal to 16 sine theta times cosine of theta plus 1. And we'll just require that theta is between 0 and pi halves. Okay, I'm going to let you guys catch up because I think there's some key language here that we need to make sure we kind of cover here. And we'll make sense of what's going on here as well. What I want us to do with this information is find the angle theta, that maximizes the area. Okay, that's our whole problem. Okay. Let's think about this. If I gave you a flat piece of aluminum, 12 inches wide, here it is. Boom. 12 inches. Now on either side of this, I marked off how far into it? 4 inches. So I'm just going to cut 4 and I'm going to fold it up, right? So this flat piece turns into something like this. Looks like a rain gutter. And I'll try to draw it to scale. About that. That's 4 inches, that's 4 inches, and that's 4 inches. Now I take this 4-inch piece and I fold it up. Where would theta be, do you think? Where would theta be? Just to make sense of this. So, like, it's weird to kind of refer to it. Can somebody come point where you think theta is? Do you have an idea, Ava? Between the fold, like here? Okay, that's a good thought. It could be. We're going to put it on the outside. There's my angle theta. Because we just folded up theta radians, however far it is. Okay. Now, does it seem like it's going to be a crazy hard problem? Kind of. The context makes it seem that way. But yeah, check this out. Don't erase yours because we just spent all that time writing it. Okay, pretend like, don't do it, don't you do it. Okay, if I just have this and said, find me the maximum, could you do it? How? How did we find the maximums yesterday? Yeah, let's take the derivative and set it equal to what? 0, and then check those, what are those numbers called? The critical numbers, and we'll also check the what's? The endpoints. Okay, yeah. This problem seems so hard with context, but it's the same problems we were doing yesterday, just with some words instead. So, what is a little bit harder as this function gets a little bit uglier? I need a prime of theta. What's a constant multiple here?
16.
Okay, let's just take that one out. We'll just let it kind of hang out. What rule are we going to need for the inside? I need product. Help me out here. First. Oh, nope. Sine. I like that. First function is sine.
First time's derivative of the second.
Okay, what's the derivative of this piece?
Oh, of course, yes.
Negative. Okay, really quick. I could write it like this, negative sine theta right here. Why would I avoid that, do you think? It looks like what? Subtraction. Is there a better way I could write it? Here's the sine theta, and negative 1 out here. I just moved, instead of multiplying by negative sine, I just moved the negative out front. And I bet I cleaned this up on the next step as well. But here's first times the derivative of the second, plus the second, which is what? Okay. Times the derivative of the first. That's it.
What would we do in like the rule where it's like do the derivative of the outside with the inside staying?
If this had been cosine of 2 theta or something, we would need our chain rule. But because our argument is just theta, we can still do the chain rule, but what's d theta?
What?
What's the derivative of theta?
Oh, I don't know.
It's what?
I don't know.
Okay, what's the derivative of x? Okay, what's the derivative of theta? Yeah. So you can still chain rule it, but it's not really happening.
But it's like.
All right, we should probably clean this guy up a little bit. No, we do have to. Because your calculator is going to give you infinitely many answers. Okay, let's check. What is this? Rewrite this better. Negative sine squared. Okay, let's distribute. Plus cos squared. Plus 1. Not plus 1. What am I doing? Plus what? cosine theta. Thank you. Everybody okay with what we've done? Gosh, there's some things that are kind of looking familiar to me.
Cosine theta is, cosine of 0 is 1.
We're gonna kick it old school here. I already hear Ava saying it, so I don't believe you. Sine squared theta plus cosine squared theta is 1. We're going to make a decision. Do you want to replace, like, notice what we have, more cosine stuff in here, right? Yeah. Do you want to replace sine with cosines, or do you want to replace cosines with sines?
No, cosine.
Let's replace this sine with cosine stuff. It'll be so much nicer because there's already another cosine hanging out here. I bet we can factor it. I bet we can. We'll see. All right. Using this, if you wanted to solve for sine, what would it give you? Or for negative sine squared? Yes. Because this is cosine squared minus sine squared. It's not quite the same. But I think I can do this. Can I subtract 1 and subtract a negative sine squared? Yeah. Do you guys agree that by rearranging that, I obtain this? Negative sine squared theta is equal to cosine squared theta minus 1?
Yeah. Plug that in.
I'm going to plug that in right here.
Okay.
Now, I don't expect you guys to remember a whole lot of trig stuff. I mean, don't get me wrong, there's things I need you to remember and that we'll keep hitting. You need to know the first quadrant of the unit circle, or at least be able to do it. I don't care if you memorize it off the top of your head. Does everybody remember this identity?
Yeah.
Okay.
No, I don't.
This one?
I don't know.
Okay. Let's check it out. So I still have 16, and then inside, what does this get replaced with?
Cosine squared theta.
Okay, can I think ahead a little bit? This is going to be cos squared plus cos squared. 2 cos squared plus cosine theta minus 1. Cool with that? I skipped one step. I just rearranged stuff. Okay. Well, shoot. This is kind of looks like it's 2u squared plus u minus 1. We can factor it. Can you give me factors of negative 2 that add up to positive 1? 2 and negative 1. So check it out. This is 16. And I'm going to use parentheses inside, but I have 2 cosine squared theta minus 2 cosine theta plus cos theta minus 1. I very intentionally left some awkward space in there because we're playing this, hey, let's review factoring stuff. What do you take out of the first one?
2.
Go on.
Cosine.
Okay.
Theta.
2 cosine theta. Do you want me to factor in 2 steps, or do you think we can do it in 1?
We do it in 1.
That's going to leave behind a cos theta minus 1, right? What would you factor out of this one? Nope, to leave behind cos theta minus 1. 1. So here's one of them. 2 cos theta plus 1. The other one is cos theta minus 1. We're factoring with grouping. I just did the pull out the 2 cos and the 1 and put them together in one step. Would anybody like to see that middle step? Okay. If you need to come up and look, I'm just going to sneak it in here, okay? That's 2 cos theta. And it leaves behind a cos theta minus 1. Then I'm going to factor out a 1, and it will leave behind a cos theta minus 1.
Oh, and then, okay.
Yep, I was just skipping over that one little piece. If you need to include it, please do. All right, well, I got a prime of theta, and I got it cleaned up pretty nicely. What do I want to set this equal to? Okay. Man, sure, I'll write it all. What would you want me to divide each side by first? Good choice. So it's really 0 is equal to 2 cos theta plus 1 times cos theta minus 1. All right, speaking of that first quadrant of the unit circle, here we are.
Wow.
If we ZPP'd,
ZPP.
let's see. When is cosine of theta equal to negative 1/2? When is cosine theta equal to negative 1/2 if I ZPP'd with this? Shane, you paying attention?
Look.
Well, nope, don't look. Let's look at our pages. Let's build it up real quick. Okay, this first one, that's pi 6. What's this ordered pair?
That is 3.
Okay,
It's the top one.
this one is pi thirds, and this is my 1/2 root 3 over 2.
Yes.
Okay, I need to know this one's going to spit out negative 1/2, right?
Yeah.
It's going to be here, and it's going to be here. 1 pi third, 2 pi thirds. So that's theta is 2 pi thirds. 3 pi thirds right here. How many pi thirds? 4 pi thirds. That's from the first factor. This one's easier. When is cosine theta equal to a positive 1? Here's positive 1. 0 or 2 pi or 4 pi or 6 pi. Now, I'm going to put 0 for this. How many critical numbers do we find? 3. Now, we need to think, though, because trig stuff, remember, it goes around forever, right? So I would make the argument there's really infinitely many here if I put the plus 2n pi's on. Okay, this is why I didn't want you to use your calculator, because there's going to be infinitely many of them. However, what interval are we working on? 0 to pi halves. Is this in it? No. Is this in it? No. Huh. Okay. I'm cool with 0 if you guys are. 0 is in it, right? It's between 0 and that. And let's see. Did I factor wrong? I might have factored wrong. Anybody notice I factored wrong? We just played that whole game. Did I factor wrong? Oh my goodness. Factors of negative 2 that add up to 1.
2.
And what did we use? Son of a gun. Anybody notice that when we made it? Me neither, unfortunately. Let's see what it changes. That and that. Are you guys okay with factoring? Like, can I just say, let's fix the mistake real quick? We factored backwards. This should be, let's see, 2 cosine theta minus 1. What it should come out to be here. Can I just fix the factors? I want you guys to put this and physically write it. Factored. Wrong. Don't erase it. Own it. I used negative 2 and 1. And I guess we used negative 2 and 1. It was 2 and negative 1, though. Everybody can factor? Okay. So let me cross those out. I'm just going to do this. Here they are. It's 16. I don't know why I need that. It's 2 cos theta minus 1. And it's cos theta plus 1. Sorry, my bad. Yeah, when I got 0 and thought, it's probably not going to happen at 0. But we're okay. You noticed I made a mistake?
No, I didn't notice, but I was like, why is it? I don't know, because you should count the negative 1.
Yep. If you're ever confused about something, and I just want to stress it, ask, and maybe we would have seen that before. But we'll survive. This changes things a little bit. Still going to divide by 16. When is this equal to 0? Where is cosine of theta equal to 1/2 between 0 and pi halves? How many radians is right here? Pi thirds. So that answers pi thirds. Now, it would happen again at 5 pi thirds, but why don't I care about it? Yes.
Theta, not x.
Yep. Why don't I care about 5 pi thirds down here?
Because it's not in our interval.
Yeah, it's not in the interval. When is cosine theta equal to negative 1? Why don't I care?
Because it's not in our interval.
Okay. What do we call this number? What do we just find? Okay, write that down, make sure we have it. Crit number. All right. Now I'm going to pick a theta, and I'm going to plug it into a of theta. Notice, a of theta is the original. What's the first thing that I would plug into my function? Extrema can happen at critical numbers or endpoints. What's the first endpoint? Okay, and then the critical number? Pi thirds, and the other endpoint?
On the top of that, is that a 0?
Here?
Down. On the
Here?
chart that?
That's a theta.
Oh, okay.
I'll make it a nicer theta. All right. Where do we plug this in? The original area equation that we have. So, using this, let's just look. If I plug in 0, what's sine of 0? 0 times, I don't care, right? It's 0. Okay. If the angle is 0, there's no area. That makes sense. It's just a straight line. You can't take its area. Let's do pi halves because that's an easy one. At pi halves, and I'm just plugging into here, what's the sine of pi halves? Here's pi halves. It's 1. So that'd be 16 times 1. What's cosine of pi halves?
0.
Plus 1.
1.
So if it's at pi halves, the area is 16. Pi thirds is the only one we have to check. Oh, gross. Okay. Here we go. Let's plug in pi thirds. What's the sine of pi thirds? Okay. Times what's the cosine of pi thirds? It's 1/2 plus 1? 3 halves. All right. I don't know this number off the top of my head. When I look at this number, I want to call this 12 root 3. Because 16 over 4 is 4. This 3 still hangs out. I think this becomes 12 root 3. Okay, I don't have a I have a calculator in front of me. Is root 3 bigger than 1.5?
Maybe. No.
What?
No. Yeah, maybe.
So I guess I'm asking before you just type it in. I want to see just you guys' reasoning. What's bigger, 12 root 3 or 16? Think so? Okay, if you don't know, that's okay. Ask your calculator. Ask it what 12 root 3 is. How do you get it so it doesn't just give you 12 root 3 again as an answer? Mm-hmm. I think it's going to be bigger. It is bigger? 20.79?
What's root 3 like? 1.7.
I might have just looked at the textbook. Yeah, I wanted to pretend like I was thinking it out. Okay, what was the question actually asking?
5 theta, then that's not the area.
Okay,
Biggest number?
the area is maximized, bless you, when theta is what?
When theta is equal to pi thirds.
Boom. Barring the silly factoring mistake, which my bad. Sorry, I didn't notice it, guys. Is that problem any different?
No.
Trig stuff makes it a little harder? Or a lot harder, depending on how comfortable you are with trig. Okay. What do I want you to do? You want real world problems?
No. I want to get comfortable with regular.
Okay.
I want to rest.
What are we doing in physics today?
Let's do homework.
Finishing your test.
No, we get to sleep in.
Oh, yeah. Already done.
All right. Homework. Thank you for being on the ball back there. What did I give last year?
Is it in here or is it with?
It's with Miss Pool. Last day with Miss Pool. And then I got to do your recommendation thing today. I promise everybody else I'm doing them. I just have a lot going on.
I'm asked. Give me a letter of
That's why
recommendation.
I'll write the best.
Yeah, I did several of them before I left. All right, here we go. This is going to be 12, 14, 21. Homework 4.2.2. You will find this on page 298. I want you guys to do 19 to 25 odd. 48. And 58. We don't have class tomorrow. Well, you have class, just not my class. Okay. Ouch. Ouch. The cut had already been made. I don't think there's one. I need stitches. All right. I want you guys to spend a few minutes working on these. They're pretty mathy. They're not really word problems. To find an extrema, there's really only two things you do. Take the derivative, set it equal to what? 0, or where it's undefined, right? Which we haven't seen one like that yet. If I had a derivative come out like something like this. If I said f prime of x is equal to, I don't know, maybe it was a natural log problem, and I had 2x plus 1 over x squared plus x. Can you tell me where the numerator is 0? Negative 1/2. That's a critical number because the derivative was 0. Are there any values that make my denominator 0?
0.
That is a critical number because the derivative is undefined. If it's a quotient, make sure you check for the undefined portions. Cool, cool, cool? Swizzy. You guys have like 12 minutes. Spend some time working on it.